So the moles question from Feb-March 2017 session, the first part, we have barium carbonate decomposed when heated. When we supply heat energy to barium carbonate, it decomposes to barium oxide plus carbon dioxide. A student heated 10 grams sample of a barium carbonate until it was fully decomposed. Calculate the number of moles of barium carbonate. We have the mass of barium carbonate.
So
Yeah. How to
Mass,
get the moles?
moles equal
mass
mass
over
over
molar
molar gram.
mass.
So
Mass
moles,
over molar mass.
yeah, that's right. Moles equal mass in gram divided by the molar mass or relative molecular mass because it's a molecule. And mass in gram equals to 10. What about the molar mass? So for molar mass, we have to use a periodic table. Because,
Oxygen equals 16 by 3 and carbon equals 12.
yeah. And barium also we have to use because it's for barium oxide, barium carbonate. So we have to,
197.
okay. And whenever you are using a formula, you always use for one mole. Like example, student, they check the equation sometime, but you have to use only for one mole in a molar mass. Molar mass means mass of one mole. So here is a periodic table image. And you want to find for barium, yeah, 197 is a total, but roughly what you said, it's, so you have barium is there, 137, carbon is there 12, and oxygen is there 16. So when we work out the moles for barium, so barium is a 137 plus carbon is 12 plus oxygen 16 times 3. So it will be 10 divided by
197 equals
197. Yeah.
0.05.
Yeah, so that's right. It will be 0.05 moles. So we have 0.05 moles of barium carbonate. Then next is calculate the volume of a carbon dioxide gas produced at room temperature and pressure, and your answer should be in decimeter cube.
Volume in decimeter cube multiplied by 24.
Good. But the first
Moles
thing,
actually. Moles into 24 equals volume in decimeter cube.
yeah. But the first thing, because we have the moles of barium carbonate and we don't have any information about carbon dioxide. So what we should do first to get the moles, because we need first moles to get the molar to get the volume.
So,
So
Mr.
what?
Use ratio?
Yeah, we will
It is
use a ratio
0.05.
between barium carbonate and carbon dioxide as according to equation, the ratio is 1:1. So ratio is 1:1. If we have 0.05, this will be X mole, so that will be 0.05 mole. But now we have moles equal volume of the gas divided by 24.
0.05 into 24, which is 1.2.
And that will always be in decimeter cube because this is, if it was in cm, then it will be 24,000 here. So this is 1.2 decimeter cube. The next, now a student add 2 grams of barium oxide, like the barium oxide which was produced, student added to water and it turned into barium hydroxide. Calculate the mass of a barium hydroxide that could be made from 2 grams of barium oxide. Look, if the mass is given, you can take the mass ratio. If moles are given, you will take the moles ratio. So
We
we
can
want,
find moles. 2
there
over
are, yeah, there are two ways to do this question. One is first you find the moles of barium oxide. Then from moles of barium oxide, you get moles of barium hydroxide. And from moles of barium hydroxide, you multiply by molar mass, you get mass in gram. This is one way. But that is like using like lengthy method, and it's of only 1 mark. So if mass is given, you can also take a mass ratio. How to take a mass ratio for barium oxide and barium hydroxide? So you, when you check the periodic table, barium is, we already did, that was 137. So we have barium is there 137 and oxygen is there. So 137 plus 60 because one oxygen is there. So that will make 153. So barium oxide is 153. So if this is 153, barium hydroxide, this is 137. Barium is 137, oxygen is 16 times 2, 32 plus hydrogen 1 into 2. So 137 plus 32 plus 2. What's the final answer? 137 plus 64. 190.
171.
What you said? Sorry.
171.
171. Okay. So 171 is a mass ratio. So if we have 2 grams, then this will be X. Cross multiply. So when we cross multiply, it will be 171 times 2 divided by 153. This will be value for X. So 171 times 2 divided by 153.
2.235.
So 2.235 grams, or usually we write answer in 3 significant figures. So I can round off this 2.235 to 2.24. The next part C, 1.5 gram of a barium hydroxide was dissolved in water. Now, like barium hydroxide, we make a solution, then total volume of a solution is 100 cm3. Then out of 100 cm3, we took a 25 cm3 portion. Like for what we did, we took 100 cm3 of water and we add this 1.5. We add this 1.5 grams of a barium hydroxide to the 100 cm3 of water. But for titration, we just took out, like out of 100 cm3, we just take a 25 cm3 sample and we titrated with the hydrochloric acid. So 25 cm3 portion of a barium hydroxide solution was titrated against the hydrochloric acid. The volume of the hydrochloric acid was 18.75. Calculate how many moles of barium hydroxide were there in 25 cm3 portion used in titration.
Mass over molar mass.
Yeah, but the thing is, if you check, like, first we will find the total moles which we took in 100 cm3, but we did not take 100 cm3, we just took 25 cm3. So first we'll find the moles in 100 cm3 and then take a ratio, what will be the moles in 25 cm3.
To find for 25.
We find for 25. So example, for first to get the moles, we'll use a formula moles equal mass in gram, which is 1.5 divided by molar mass of a barium hydroxide. That was 171. We did that in the previous. So 1.5 divided by 171. What's the answer? 1.5 divided by 171.
2.77 multiply 10 power negative 3.
So 2.77
or Mr. 0.0087.
Yeah. So what is the meaning of titrated? Means like it is reacted. Like what we did in this experiment, we make a solution. Like we have a solution of a barium hydroxide, which is 100 centimeter cube. This solution was 100 cm cube, which contained dissolved barium hydroxide. But out of 100 cm cube, we took out 25. Like we transferred that into a conical flask. We transferred 25 cm cube of barium hydroxide into a conical flask. And then we titrated with hydrochloric acid, means we reacted or work out the concentration by using a titration. Like we will add some drops of indicator, a suitable indicator will be added, and the burette is filled with HCl. So when burette is filled with HCl, that HCl is added to barium hydroxide. How much HCl is needed for a complete reaction? with barium hydroxide, that is 18.75 cm cube. So 25 cm cube of barium hydroxide required 18.75 cm cube of hydrochloric acid for complete reaction. That's they mean by titrated with, or was the barium hydroxide solution was titrated against hydrochloric acid. Then the next part here, because we want how many moles of barium hydroxide in 25 in this one, but original solution was not 25, original solution was 100. So first we'll find how many moles are there in 100. Moles equal mass in gram, which is 1.5 divided by molar mass, 171. So that was 0.00877. These are the moles, but these are the moles in what? These are the moles in 100 cm cube. But we did not take 100 cm cube. How much we took? We took only 25 cm cube. So in 25 cm cube, how much it will be? It will be x moles. Just cross multiply. So it will be 25 into 0.0087 and divided by 100. So that is equals to 0.0021 mole, or 22 you can also say, because it is 219, so I can say 22. Is it clear? C1?
Yes, sir. Clear.
What about others? Anyone having a doubt in this?
No, sir, clear.
Then the next one is calculate the concentration of a hydrochloric acid used. So
Concentration is moles over volume.
concentration
Volume
is
is 18.75 and the moles are double that of barium hydroxide.
so we need the concentration of a hydrochloric acid to get the concentration is moles over volume. But we don't have any moles of hydrochloric acid, as you can see. Like we have moles of barium hydroxide. So first what we have to do, we have to use a ratio between barium hydroxide and hydrochloric acid to get them. We have the volume. That volume is already, but keep one thing in mind, volume should be in decimeter cube. We have the volume of hydrochloric acid, that is in cm cube, which is 18.75. So we divide by 1000 to convert into decimeter cube, which is 0.01875. But what about the moles? How to work out the moles? Moles equal, we have to take a ratio here between hydrochloric acid and barium hydroxide. The ratio is 1:2. So if ratio is 1:2 and we have the moles which are present here 0.0022, then this will be x moles will be reacted according to equation. So we cross multiply. So it will be double of that
0.0044.
44. So 0.0044 divided by 0.01875. What's the answer? This will give us the concentration 0.23, I think. Moles per
0.23.
moles per decimeter cube. So that's how we work out the concentration. So first thing, we got the moles of barium hydroxide, but that moles, they did not ask for total moles, they only asked for 25 cm cube. That's why first we got the total moles which are there in 100, and 25 it will be x. We got the moles. And after getting a moles, we took a ratio to get the moles of hydrochloric acid, and moles of hydrochloric acid divided by volume of hydrochloric acid, we'll get the concentration of HCl. Yeah, it is fine. If you take 0.0187, that is also fine. So this was a 7-mark question from Feb March session.